Hello, and welcome to my presentation on a randomized controlled trial on embedded computer language switching. I'm Merlin Drews, and my co-authors were Cole Peterson, Bonita Sharif, and Andreas Stefik. So, to talk about computer language switching, we first have to talk about polyglot programming. Polyglot programming is the activity in software development where we switch between programming languages to develop something that includes having to read code, having to change code, having to write new code, and doing that in multiple programming languages. And this is actually really prevalent in software development. When you look at open source repositories, you find that 97% of open source repositories actually have more than one computer language. That averages up to 5 per project. And generally, we found that there's like about 24 general purpose programming languages in common use today. Also, when you ask programmers how many programming languages they know well, they say 6 and 10 overall. So that's also really interesting when you think about all the knowledge that a developer needs to have to be able to keep up with all those languages. Also, one motivation of all of this is, hey, how much does it actually cost when we develop software? And there's 103,000 median salary for US developers. There are about 1.2 million developers in the United States, and the software industry is a $407.3 billion industry. This means that if we can help improve some development time, even if it's just 1% or 2%, we could actually cut down significant costs across the industry. So we are hoping to be able to do that with our research at least a little bit, or move in the right direction at least. Also, there's a personal stake in this whole programming language switching thing, in that when I was a grad student, we had to switch between programming languages a bunch to be able to build all the things we wanted to build. One of the things was we had to switch between a programming language with and one without semicolons, and I found myself mixing that up all the time, for example. But there's also other perspectives on this, like maybe a language doesn't have a for loop, maybe a language doesn't have a while loop, or something like this. You keep forgetting the languages look similar, and really is confusing. So I was looking into research on what we could find regarding this, and I didn't really find much in computer science other than that developers actually use similar brain areas when they switch between, when they read code as when they read text, normal natural language text. So when I didn't find anything in computer science on computer language switching, I decided to look into linguistics. In linguistics, there is a phenomenon called code switching. And I looked into that a little bit, and it's really interesting, a little bit out of the scope of this talk, but they essentially found that there is a time cost to switching between languages, even in speakers that do it really often and really quickly. You can still measure a hesitation when switching between languages. So I was wondering if we could find a similar effect in polyglot programming as well, since we saw that like maybe the brain areas are related and stuff. So for that, I wanted to first think about what kind of switches there are in computer language switching. And the one most obvious one is like we work on a project, it's PHP, mainly maybe some JavaScript, HTML, and then we switch to something else, like maybe it's another web project, but it has a Java backend or something. And so we like switch between projects. Maybe that's on a daily basis. For some, it might be every couple months they switch a project for work or something. But it is certainly a switch that could happen, and it's a switch between sets of languages that happens a lot, I think. Then there's the file switching, which is a switch between 2 files in the same project that have different programming languages. So for one, maybe we're writing some code on the back end exposing some API endpoint or something in PHP, and then you switch to JavaScript to send a request to that endpoint. But this could happen more rapidly than the project level switch, but also it's not quite clear how often this does happen. And then there's the embedded switch. That's the one that we want to talk about here, because that was really relevant for one of our projects. We wanted to see, hey, how do we actually query databases? And one pattern that we found was that JDBC, for example, lets you embed SQL strings into Java statements. So like you're like, oh, cool, here, execute this query, and then you write a string and it has a SQL in it. And that happens within a file, right? Like you write some code for database communication, and it just executes a query, sends stuff to the database, gets stuff back. When you write this code, you have to switch between Java and SQL and switch back to Java, or maybe even back and forth, depending on how you develop this. And I was wondering, what does this affect? How does this affect people? And for this, we set out with 3 research questions that came from this this interest in this. For one, is there measurable difference in productivity between programmers when programmers switch between programming languages? The second one was, do people actually consciously experience switches between computer languages? And the third was, hey, is there a difference in productivity between participants who speak English natively and those who don't? That's a kind of a secondary question that came up during the look into natural language research in this regard, and we were interested to give this a shot. We were not really satisfied with the results in this paper, and this needs some more in-depth work, but we'll get to that later. So for this to work, we needed an environment to run our experiment in. So we use our experiment code, our experiment platform. It's a web platform. On the right side, you can now see a screenshot with highlighted areas of which of our platform on how we look at code snapshots that it records. It also records task time by automatically testing the code when a participant says, "I'm ready, try this," and then it runs automatic test cases against it. And this is how we record our time, the time that we care about in productivity. It has automated consent form. It has automated randomization, code editor, and it also records all these snapshots that we can scroll through on this page that I'm showing there, and the outputs that it generated at the time. And otherwise, it looks like this. It has a bunch of survey up front that we can also technically change, but we mostly use the same one. It records all kinds of information about their status of education, their age, their gender, if they want to disclose it, their experience with different programming languages, and their experience in different classes. Then we have the hard piece of this application is actually the view where on the right side we have an editor where they can write their code. And on the left side, we have samples that help them understand what they need to write, and instructions and stuff that also go on the left side. And further down, there's a button that you can press to compile the code and have it tested, and also output for what the compiler actually tells us, or the test case tells us. So let's go to the study design that we actually came up with using this tool. Also, we made a repeated measures design, double blind, of course. We measured time as productivity. That means time until tasks were complete. I alluded to them a couple of times. We have these test cases. We write test cases for each task. The test cases have to be satisfied to be able to move on with the task. And when they are satisfied, or the 45-minute timer runs out, the task is ended. So a successful task is some time under 45 minutes, and it only ends when you satisfy the test cases. And so we wanted to make participants switch between the host language and the embedded language. For that, we made 3 groups. I'll go through the details of these later, but basically there's a string group that is the standard polyglot implementation. They have to switch between Java and SQL. We have the object-oriented group, that's the monoglot implementation. They have a library that's built into the experiment where you can write all the queries just in Java. And then we have a hybrid group where the difficult parts of the object-oriented implementation are done in string-based conditions. So we were hoping that would be the easiest group to use. It is kind of a different implementation of Polyglot, where you might argue it's a quicker switch to a not as complete a switch for Polyglot. So when we look at those, here you can see, you write some code and here's some Java code, and then you add the SQL query as highlighted here in a string. Then you have the object-oriented group where you don't have the only strings are the names of the columns, and you build the query conditions, for example, with a chain of method calls. And then we have the hybrid group where the condition is replaced by a string instead, because it's easier, in our opinion, to write. And then we come to the results of the actual experiment. So we ran this. We had 109 participants that finished the experiment. 33% of those were female. We had about the mean age of participants was 24. We had 75% of the people were native English speakers, and as you can see in the box plot on the right side, we had about even performance for our hybrid and string-based groups. Obviously, the y-axis is time in seconds to complete tasks on average. So lower is better. Basically, is higher productivity, and higher is worse. And you can see in the object-oriented group that they were slower than the other 2 groups. We ran an ANOVA on this. We found a significant effect for the difference between groups with a small effect size of 3.9% of the variance accounted for. When we look at the graph, we see the graph of broken down by group and experience level. We see that the hybrid group is relatively good across the board, while the string-based group has freshmen and sophomores failing a lot of tasks. They're hitting the ceiling time, the maximum time you can take, and then having a little bit better performance for the juniors, seniors, and professionals than the hybrid group. And then the object-oriented group has the first 3 levels, failing a lot of tasks, and the other 2 doing okay, mostly. Since I'm talking about failing tasks, here's the bar graph of the failure rates, so the amount of time people have failed tasks completely in the different groups, but broken down also again by experience. You can see the failure rate in the hybrid group is generally low. The failure rate in the string-based group is higher for the first 2, the freshmen and sophomores. Object-oriented group, the failure rate is relatively high across the board, but for professionals and seniors, and pretty high for freshmen especially. Then here's the graph representing the difference between English as a primary language. We did find a significant difference between they have primary English knowledge and they don't. One problem with this is that we recorded a primary English skill by asking them in the survey if they're primary English speakers, and we found some really mixed answers from people that are clearly also primary English speakers, and some people that didn't feel like they are primary English speakers that still have really high English skills. It's kind of messy. And after talking with some linguists about this, it should have probably been better assessed by using proper English proficiency exam, like a TOEFL score, for example. And therefore, I wouldn't put too much stake in these results. So when we come to a results overview, we did find a difference between groups. It's a small effect. The monoglot group did the worst, so the object-oriented group did the worst, basically. The string-based group did okay with more experienced people, but not so good with beginners. We think that is mostly because the more experienced developers also have more experience with SQL or the ideas of SQL, and the hybrid group did the best. I think it was because it was very simple of a design compared to the other ones, and it seemed to be very easy for the beginners also to understand. We did find significant differences between primary and natural languages, but we are not so sure that those results are actually generalizable. Also, we found that monoglot can be overall, we found that monoglot can be difficult, especially when it's hard to express certain ideas like these conditions in monoglot format. And there are clearly differences between different ways of doing programming language switching polyglot. And with that, we come to the end. I thank you very much for watching, and please check out our replication packet. You can find it under this URL. We got 3 badges for it, available, reusable, and functional. We hope you'll find interesting stuff with our replication package. We included data analysis scripts, screenshots. We had also the source code for the environment we used to do the experiment with. So I hope you can do something cool with this if you're interested. And thank you very much.